Thank you for viewing this recorded Reliable Automatic Sprinkler Company webinar. Should you have any questions regarding this presentation, please feel free to contact Reliable Technical Services at 800-557-2726 or email us at techserve@reliablesprinkler.com. For upcoming webcasts and an archive of past webcasts, please visit reliablesprinkler.com/webcasts. Once again, thank you and enjoy the presentation.
Thank you everybody for attending today. As we mentioned before, we're going to discuss window sprinklers and how they're used. If you looked at the Reliable product portfolio up until very recently, when we talked about window sprinklers or window nozzles, it mainly revolved around our Model B and our Model FM, primarily used for deluge applications to protect windows from exposure issues. That isn't what today's presentation is going to focus on. What we're going to focus on is what a specific application window sprinkler is and what we have to offer in that regard. First and foremost, specific application window sprinklers fall into the categorization of a special sprinkler outlined in NFPA 13. These are sprinklers that NFPA 13 isn't going to spend a lot of time detailing how to design and use these types of products, but allows manufacturers to pursue special products and listings and approvals with various laboratories that are involved with fire protection, fire sprinkler products. When you're going to create a special sprinkler for NFPA 13 purposes, you're going to have to follow those 7 bullet points, 7 numbered items that you see on the screen here. Number 1 being a fire test that's related to the intended hazard. How is this sprinkler going to interact with a window? Check the distribution of spray pattern with respect to wetting of floors, walls, and in this case, a window, which is part of the wall assembly, and distribution of the spray pattern with respect to obstructions. There are going to be various obstructions with windows that we need to be taking into account with our testing process. Evaluation of thermal sensitivity of the sprinkler, making sure that it operates quickly if we need it to. Performance under horizontal slip ceilings doesn't really appear like it matters too much with window sprinklers, but it could. And we're going to talk about how the ceiling does or does not impact this product later on in the presentation. Area of design, really how we're going to design this product and make it work with our hydraulics and the overall design of the system. And then allowable clearance to ceilings is also going to be detailed as well. If we think about protecting windows with sprinklers, a lot of the sprinkler industry just wants to default on using standard spray pendant products. NFPA 13 has detailed certain scenarios where that's considered acceptable. And what we're trying to do today, though, is talk about using a sprinkler that's meant to be used in a fire-rated assembly, which is a bit different than just protecting glazing. If we do look at using standard spray pendant products, we have to understand that they are designed and developed to cover a floor area with a spray pattern and certain density of water. And if you apply that to a window, it really doesn't work because it's not designed or intended to do that. With the umbrella spray pattern offered by standard spray products, you're just naturally going to have wet spots, primarily at the top of the glazing, mainly in the corners, farthest point away from the sprinklers. And these dry spots are going to be very detrimental in a fire incident that's going to allow that glazing to get heated and potentially fail. If we look at the specific application window sprinklers, they're designed to wet the surface of the window. They don't care about the floor down below. So the spray pattern is flat, it's high, and it just focuses on creating a situation where we cover the top of the window and we allow gravity and the water to cascade down the surface and completely cover it. And that's what provides the insulative properties against fire heating the glazing. In order to create one of these products, we would visit UL Laboratories and we would test against 2 different documents that they have there available for this type of product. Number 1 being the ULC ORD C263.1-99 or the UL 199J. If we talk about the test procedure detailed in the ORD, the other recognized document, this is the one that's going to focus on testing the window sprinkler inside of a furnace. And we're going to have a heat source that's a gas burner. It's going to implement closed sprinklers. And we're going to also need to have this test run for the duration of the equivalency that we want the window assembly to be rated at for fire resistance. And in order to successfully pass this test, we're going to have to, number one, let the time elapse for the fire rating equivalency. We're also going to take some measurements of temperatures, number one being the average temperature of 284 degrees, not exceeded on the unexposed surface. So multiple thermocouples, taking multiple readings, and then we're averaging them together. And then the temperature of 356 degrees Fahrenheit, not exceeded an individual thermocouple on the exterior. That's for a time period greater than 40 seconds. And after this whole test, we have to inspect the window, make sure that no opening has been created in this assembly. Otherwise, we would end up failing the fire rating equivalency. This whole test procedure can sort of be more simplified into saying that we're going to test heat strengthened glazing and tempered glazing materials, and we're also going to have a requirement to keep those combustibles 2 inches away from the glazing surface with this type of test. If we take a look at the test, it's going to be done in this furnace. Here's a section of it you can see here. And we have our sprinkler installed with the glazing material. We have a gas burner located in the back. Underneath of that, we have a supply of air to fan that flame and keep it going. We have an exhaust duct to help exhaust byproducts of combustion out there, allowing that flame to keep on burning. And we need to have provisions for drainage, because if the sprinklers are going to activate and we're going to run this test for a very long time, we need to be able to get that water out of this furnace assembly and not let it begin to fill up. There are an array of thermocouples located on the exterior of the glazing. Light our fire, and then it's going to take several seconds to heat the furnace up to the point where our sprinkler will activate. But once it does, you see that special spray pattern is going to hit the window high, allow that water to cascade down, and then drain out. Now, once this sprinkler activates, it's introducing water to that glazing. This test isn't over until we pass our time limit. And what happens now is that we run this furnace for a period of up to 2 hours for the equivalency that we're seeking. And during that time, the furnace is heated up following the ASTM E119 time temperature curve. So while it looks pretty low on the left, I'd say when this sprinkler activates, it's going to be probably in the 155 degree Fahrenheit ordinary temperature range. But by that 2 hour period, that furnace is approaching 1900 degrees Fahrenheit. And you can see that you could start this test and you could be doing fine, but then maybe an hour and a half in, the glazing gets heated up and it ends up cracking and failing the test. So it's not easy. And when this test starts, when a sprinkler activates, you're not home free. You got to wait 2 hours, and you have to hope that that glazing can withstand the heat that's introduced by that furnace. So here, let's focus on giving you guys a look at this test. We have a video here. So you see just a front view of the furnace there, where we have our glazing material, and we have a vertical mullion in this particular test. Fires ignited in the back there. We have our exhaust ducts on the side. They're pulling out any kind of byproducts of combustion. We're also measuring the temperature on the front of that glazing, and ultimately just waiting for this furnace to heat up to the point where our sprinklers are going to activate. Our sprinklers are up there in that black pipe that you can see right here. And it does take a few minutes for us to get our temperature activation here for our sprinklers. And there we go, we get our activation. Now what I want to do is focus your attention right here. And you can see that we start flowing water up at the top, and it takes time for these dry spots to fill in, but eventually they are going to fill in. And that's what gives us the the sheet of water over the surface that's insulating the glazing from the heat that this furnace is generating, and it's going to allow this assembly to last for the 2-hour equivalency that we're seeking. So it's a very challenging, difficult test. It's a long test. We don't want to see failure and repeating of this test. It's a lot that goes into this, setting it up, running the test, and then setting it up for additional tests, because this isn't just one and done for us. We have multiple tests with different glazing material and mullions and butt joints and everything else. So a lot goes into passing these tests. Now, if we take a look at the other test document, UL 199J, this is a test that's performed on standalone glazing material. It uses a heat source. It's a pan of heptane that's going to create a 40 kilowatt fire, and it's going to have an open sprinkler installed, and we're going to flow water for 30 seconds as a minimum. A successful test is just not breaking the glazing. Another way to look at this type of test is that it's the one that uses fire-rated glazing material, and it doesn't have a limitation to keep the combustibles 2 inches away from the glazing surface. So just different material, and then also a different way to construct that wall assembly with this type of setup. So if we take a look at this, this is how the test is run. It's just standalone glazing, have a sprinkler installed, and then we have our fuel pan located at the bottom. Now this fuel pan is also located right up against the glass. It doesn't sit on the ground next to the frame or anything like that. It's really meant to place the fire in direct contact with the glazing material. And as I said, this is the glazing material that's going to be fire rated for at least 20 minutes as a minimum. And we have an array of thermocouples on the outside of this because we need to measure the temperature of the glazing before we activate our sprinkler. So here we have our fuel lights in the pan, and basically what we're trying to do is let that fire generate that heat and expose that glazing for 5 minutes, or to the point that gets to 932 degrees Fahrenheit. We got to do whichever one of those comes last. But ultimately, we're putting so much heat and temperature into the glazing material that when we introduce water, it's going to shock it thermally, and typically this would break regular glazing materials. But what we're doing is we're offering that 20-minute product, and we're sort of supercharging it to make it go up to 2 hours. It's a very interesting way about combining sprinklers and upgraded fire-rated materials to get the end result of 2 hours. So just a different type of test. So what we get after doing that is our Model WP window sprinkler series. These were introduced earlier this calendar year, and these are UL listed for protection of fixed glazing products. They have a demonstrated capability of 2-hour fire-rated equivalency through that testing at UL. And we have 3 glazing types that they're meant to be used with: heat strengthened, tempered, and UL listed fire protection rated glazing material. Full details about this product can be found in Bulletin 181 on our website. These are considered pendant vertical sidewalls. We have WP56 and the WP56L, so both are going to incorporate a fusible glass bulb here and a fusible link in our WP56L product. They both incorporate 5.6 K factors. We have ordinary temperature rated product and intermediate temperature rated product. And a unique feature of this product line is the maximum working pressure that goes up to 250 PSI. A lot of sprinkler products are listed at 175 because that's what NFPA 13 is set as the minimum. Reliable has focused over the years of creating products that exceed that 175 PSI minimum. So you're able to create a whole system that incorporates valves from us and sprinklers from us. And if you pair it with pipe products and fitting products from other manufacturers, you're able to have this system where the minimum, the maximum working pressure goes up to 250 PSI. So why is that an important feature? Well, basically, if you're able to build this entire system at 250 psi and you have a window sprinkler requirement, you install one window sprinkler and it's 175, it degrades the performance of your whole system down to that level. What we envision as a great application for this type of benefit of 250 psi is a multi-story high-rise that we know we have high pressure in the standpipe rising up the stairwell, and sometimes at the lower floors of the building, we're installing those pressure regulating devices or pressure reducing devices. Often they're expensive valve products. So we could actually create more floors of non-pressure regulated systems that just really can save a lot of money, because you can end up getting 75 extra psi out of your standpipe without having to worry about reducing it. So it's a really neat thing, something we're very proud to offer, along with our other products to help create these higher pressure systems. With the finishes available for this product, we offer standard finishes of bronze, chrome plate, and white, and then we also offer some special finishes. 3 of them are pretty important to talk about: the white polyester and the black polyester and the electro-nickelus PTFE. These are going to provide UL listed corrosion resistant finishes, and they are only going to be offered on the glass bulb version of the product. The fusible link version of the product offers metal products that are susceptible to corrosion, so it sort of defeats the purpose of having corrosion resistant with that finish. So you're going to be able to get the white polyester and the black polyester and nickel PTFE with all those sprinklers, but the corrosion resistance only on those glass bulb models. If we look at how to apply this product, let's talk about on the interior walls of a building. We would install these products on both sides of the glazing product, because we're, again, trying to create a fire-resistant rated wall. And in this instance, with the inside of a building, we don't know which side of the glazing the fire is going to occur on. But in order to maintain that fire-resistant rating, we have to have that product be able to, the glass product, be able to survive a fire on both sides. So sprinklers go on both sides of an interior wall. We also can use these sprinklers for some exposure applications, using them on a window that is an exterior window, placing it on the inside of the building. On the outside, we don't necessarily have to have it, maybe. It just depends on what we're trying to do with the exposure protection requirement. In this instance here, though, we are putting the sprinkler on the inside of a wall that faces the exterior. If we look at NFPA 13, it's going to state something that if you're installing sprinklers at the skylight level, you shall use a intermediate temperature rated product. NFPA 13 doesn't really specify what to do with window sprinklers. It's sort of a newer product category, might be something that they need to revisit, but we're going to have a strong recommendation that these window sprinklers on exterior walls get intermediate temperature ratings, just as a way to prevent pre-operation incidents. The sun on a side of a building is not so much different than the sun hitting the roof of a building and causing those sprinklers to potentially activate early. So if we take a look at our last application, we're installing the window sprinkler on the outside of the building. Now in this instance, this is going to be for a deluge system. So this is going to be a window sprinkler we purchase, and we would use, we would open the sprinkler up, we'd remove the operator with the glass bulb, the fusible link. This would be another area where you could look at using the model FM or the model B that we discussed earlier. So we have a lot of options for this deluge nozzle application on the outside of a building. If we take a look at the WP56 installation styles, first one we're going to look at is installing it with vertical mullions. So a vertical mullion is a metallic frame element that's going to create a separation between the panes of glazing. It's going to protrude from the glazing surface. It's going to really turn each individual glazed panel into its own hazard for the purposes of window sprinklers. In this instance, we're going to need to keep the sprinklers a minimum of 6 foot away. And this is our cold solder measurement. We can get around that 6 foot minimum, assuming that there's some type of baffle that's of sufficient depth, and that sufficient depth is going to go to the back of the deflector. This is going to allow us to consider them separated and then space them closer than 6 foot apart. If we look at this spacing in between sprinklers, the maximum, it can go all the way up to 12 foot. This is a significant increase in spacing for this type of product from what's been available in the past. It may be hard to get glazing panels with vertical mullions that are that far apart, but if they are, then there is significant benefit to having these sprinklers being able to space all the way out to 12 foot. We also have this nice design flexibility measurement of being able to space a sprinkler 7 foot maximum off of a mullion. This does go beyond the coverage area of the product, but it does offer a bit of extra flexibility for spacing this product based upon how the windows are laid out or based upon other sprinklers. Just a nice design feature to have in your tool bag, laying these systems out. The other type of windows that we're going to talk about is butt jointed windows. These are glazing panels that are separated by a silicone bead, just runs down the middle. It's really a clean aesthetic. This allows us to look like we have one continuous pane of glazing inside of a building. Now, in this instance, again, a 6 foot minimum is going to be required for these products, and then a maximum spacing of 12 foot in between them. Butt jointed products are where we're really going to always be able to probably take advantage of our 12 foot spacing. It allows us to open up the spacing and really maximize the amount of coverage area we can get per sprinkler and reduce the total number of sprinklers that are used on this project. With this in layout as well, we're going to get 7 foot off of a mullion. The nice part is just butt joints, create one continuous piece of glazing. If we look at the WP56 installation with horizontal mullions, this is where we run into some challenges. We have mullions or butt joints that are located on the top portion of the glazing right here. But what the problem is the horizontal mullion right here. So this runs horizontally across our glazing, and this is going to prevent our water from cascading down the surface of the top glazing panel and then transition to the second glazing panel. So in this instance, we're going to get coverage out of the sprinklers that are located at the top glazing panels. It's no problem there. It's meeting the listing of the product. What becomes a challenge, though, is the bottom panes. We're not going to be covering them, so what do? Do we need to add additional sprinklers? Do we use glazing material that is fire rated and just absorb the extra cost associated with that material for those panes that are on the bottom there? I don't really know. It's a design and cost function analysis that needs to be done for this type of system. Now, if we take a look at how to install these products, first thing we're going to talk about is installing this with the UL listed fire protection rated glazing material. It's a non-operable glass window, installing the sprinkler. We can use these products per their listing on a maximum exposed glazing height of 13 foot. Now that 13 foot maximum is a function of the furnace that we showed you earlier. That's as big as UL will build it. That allows us to put that piece of glazing in there. So we can't really offer a listing beyond the 13 foot because it was never tested. And then we talk about no maximum height between the floor and the ceiling, which is important because we know that the glazing is only 13 foot. Maybe we're going to have a 20 foot wall assembly that we need to drop that sprinkler down 7 foot. That's fine. There's just, again, no maximum height between these types of products. That's because these products are not intended to activate when a fire occurs and then wet the floor. That's what the ceiling sprinklers are meant to do. These are really meant to protect the window. If the fire gets near the window, if it can activate that sprinkler, then it's going to activate and discharge water on the surface of glazing and protect it in that fire event. So no maximum ceiling height is required. Now let's talk about installing this with material that's not the fire protection rated glazing material. So our heat strengthened and our tempered glazing materials. You'll see right away that we have no maximum height once again, and we have our non-operable window, but down here we have what is known as a pony wall. So a requirement of a 36-inch minimum pony wall needs to be installed in order to use these sprinklers. Now, why do we do this? Well, we showed you that standalone test where the pan of fuel was right up against the glazing material and we lit it. That fire was really meant to represent something like a waste paper basket fire. So somebody would end up installing or placing a trash can next to a piece of glazing, it lights on fire. And what ends up happening is when a fire occurs down here, a small, tiny fire, the heat generated by that fire gets absorbed by the adjacent glazing material, and it gets superheated. And by the time that waste paper basket generates enough heat to activate a sprinkler, which could be 13 feet in the air, it's going to activate discharge water on this glazing material, and it's going to be shocked thermally and then crack. So this pony wall is meant to allow that waste paper basket fire to occur down here and allow the heat to get generated but be absorbed by the pony wall material. And when the sprinkler activates, the glazing material has not been heated to the point where it's going to fail. So that's the reason why we have this requirement for the 36-inch minimum pony wall. It's really to protect those lesser strengthened glazing materials and preserve them in the instance where a fire actually sets a sprinkler off and doesn't allow the water to damage the glazing material. Now, it's also important to note that 36-inch minimum pony wall is the language that's used. It's just the easiest thing for us to build and understand. But it is possible that other method acceptable to HJ can be implemented. This could be some type of metal railing system or something else. Whatever you can imagine, whatever the HJ will accept is a possibility. But like I said, the easiest thing to understand and to build typically is a 36-inch minimum pony wall. Once we get past that, we don't have a concern about the glazing height. It still can be a maximum of 13 feet. Installing the WP56 installation dimensions here, we're going to install the sprinkler with the frame arms parallel to the glazing surface. And we're going to be able to install this 4 inches to 12 inches off of the glazing. We're going to set this sprinkler 2 to 4 inches down from the top of the frame. This is going to allow us optimal ability to project our water towards the glazing material and coat all the surfaces and then cascade down it. There will be no limitation between the sprinkler and the ceiling. When we think about these window sprinklers, they're ultimately used in architectural features, the desire to have glazing replace drywall and regular fire resistant construction materials. So when you want to put glazing in, what you really don't want to have is maybe sprinklers projecting down into the glazing and then creating an eyesore. So in order to try and conceal that sprinkler, you could build out some type of ceiling pocket arrangement that allows you to sort of hide the sprinkler, at least from maybe one vantage point of this window. And then with all windows, we have to be concerned about the need for window treatments, whether they're interior or exterior windows. Somebody might want that amount of privacy offered. So yes, you can use window sprinklers with windows and window treatments. The only key here is that you place the window sprinkler in between the window and the window treatment. If we take a look at the product's listed flows and pressures, we offer the maximum of 12-foot coverage area with a listed flow of 15 GPM. And that is also going to create a need for 7 PSI as the end sprinkler pressure. This is perfectly optimized here. I mean, a 5.6 K factor, 7 PSI being the minimum sprinkler pressure that's required by NFPA 13, resulting in 15 gallons a minute and 12 feet of coverage. So it's a really well-designed product. It maximizes as much as we can to help this go in with the hydraulics without any kind of issue. Discuss hydraulics for a second. If we look at the hydraulics section of our bulletin, this is the first sentence that shows up. The authority having jurisdiction should be consulted to determine the hydraulic requirements for each installation. And the reason why is because this product is meant to be a variance to what the building code wants to see with fire resistant construction. It's something that's not detailed how to calculate this in NFPA 13. We're going to offer the guidance that you're going to see on these few slides after this. It's in our technical bulletin, but ultimately we're going to have to get buy-in from the AHJ all the way through on how to install these products as an alternative to what the building code wants, and then how to calculate it ultimately to make them happy. So if we take a look at this, this setup here, we have a plan view of a building. We have some glazing material located up here at the top. We have, it's a 48-foot length of glazing for this example. Glass panes are 6 foot, and we have vertical mullions that are going to separate each one of these black lines there. And we're going to create a 1-hour assembly rating. We'll lay out these sprinklers. Remember, vertical mullions create an individual hazard for every pane of glazing. So every pane of glazing is going to get a sprinkler. And we do it on both sides because this is an interior. And we're going to come away with basically 16 of our window sprinklers in this case. And then the next question is, well, how do we calculate this? How do we figure this out? Well, we're going to go back to a familiar formula. It's 1.2 times the square root of the remote area. In this instance, we're going to choose a 1,500 square foot remote area. We're not going to do any kind of quick response reduction, even though that is a possibility. That's going to result in 46.5 linear feet. And we divide that by the sprinkler spacing, and that turns into 7.75 sprinklers. We have to round that up to 8 window sprinklers. So we're going to put hydraulic nodes on those sprinklers. Now what do we do? Well, this is where we got to sort of figure out where this is in the building. Is this in the remote area? If it is, then we're going to add those window sprinklers to that hydraulic calculation. We're going to run that calculation. We're going to make sure it's balanced and everything, and that's going to be our end result. If it's not in the most remote area, we're going to run the hydraulic calculation for the window sprinklers, but we're not going to add it to what is considered to be the hydraulically most remote area. But we do have a need to not just calculate the window sprinklers, but the sprinklers that are next to it as well. So in this instance, we'll add these hydraulic nodes. So worst case scenario, whether it's in the remote area or if it's not in the remote area, we're going to develop remote areas that involve the window sprinklers, but then they're also going to pick up adjacent window sprinklers, making a remote area that is complete and whole with NFPA 13. Now, if we look at this, it's a light hazard occupancy, so it's like a 0.1 density. If we look at just using like a hypothetical amount of water, it's 0.1 times 1,500 square feet turns into 150 gallons for our traditional light hazard. That'd be the hypothetical minimum if we can actually get that. We know we're going to have over discharge and maybe add some extra heads and everything else, but we're looking at 150 for the system. And then with our window sprinkler, we're going to have 8 of them. We're going to add up the 15 gallons a minute. That's 120 gallons per minute. And in total, we combine those two, and then our total demand ends up being 270 gallons per minute as a bare minimum. One thing to keep in mind about these systems when you're hydraulically calculating them is that we have to make sure that regardless of what the hazard is in NFPA 13, that the assembly rating, if it's greater than what NFPA 13 wants, then we have to consider that for our duration. Now, if we look at light hazard being a 30-minute duration, just wanting to have a 1-hour rating up here means that we need to then double our duration time from 30 minutes to 60 minutes. And now we're looking at 270 gallons a minute over the course of an hour being required for our water supply. We're going to take this same example again and run it one more time. But this time we actually have windows that are separated with butt joints. So now we have this 48-foot long glazed panel assembly here that is going to now be able to be protected using the maximum spacing for our products. We have the ability to take those 16 window sprinklers we had before and now drop it down to 8 because we can go 12 foot apart. We can maximize the spacing with this type of product in this glazing assembly. So we're just getting rid of the number of sprinklers. We're also getting rid of the number of potential aesthetic drawbacks by using these window sprinklers, because there's just less of them protruding down in front of the glazing. We're also going to run this by reducing the remote area using the quick response reduction. We can go down to 900 square feet now. So 1.2 times 900 square root of 900 feet is 36 linear feet. And we divide that by 12, the spacing of the sprinklers, and we're down to 3 sprinklers. So we're 3 window sprinklers added to our hydraulic calculation. With the remote area, same situation as before. Nothing changes because of the glazing material or because of the quick response reduction. So we're adding more sprinklers to our hydraulic calculation. Again, it's going to be a light hazard calculation. The demand of the system could be 90 gallons per minute, 0.1 times 900. Our window sprinklers, we're down to 3. So now we're going to flow 15 gallons per minute times 3, 45 gallons per minute minimum. And then adding those together, our total demand now is 135. Just like before, we have to make sure that the duration of the window is going to be able to last with the water supply. So now, looking back at our first card over here, it is a 2-hour assembly. That means that the 135 is going to now have to last up to 120 minutes. So it's a big difference from light hazard, from 30-minute supply to now needing to go for 2 hours. So if we're concerned about the duration of our water supply, then we need to be aware of these things with our hydraulic calculations and make sure that they can last for the whole period of the duration required of the window assembly. So those are just some really high-level hydraulics. Again, it's got to go through the process of approval with the AHJ, and we've given a lot of detail in our bulletin on how to do this, and it's in line with what's been accepted in the past industry-wide. But it is really important that we engage them and get them on board with not only using these sprinklers, but then how they're calculated, because an AHJ could change what's in our bulletin just because they feel that it's better, and that's what they want. Now, one thing that we're real excited to talk to you about is our newest product introduction that came out last month, and that is our WP56C product. This is taking that window sprinkler and now concealing it behind a flat plate. We feel that this is enabling the architects out there that want glazing to offer it in a way that they've never been able to before, one that makes sprinklers pretty much completely hidden. And all it requires is that from the very beginning of the project, the architect identifies this is the aesthetic that's wanted, and they build the wall assembly, the ceiling assembly, the glazing assembly around this product. But that's the key to this: getting in early, building the assembly to take advantage of the sprinklers aesthetics, and you can really achieve something that's never been achieved before architecturally. Just like we discussed before, this sprinkler went through the UL listing testing that we talked about. It has the equivalency of up to 2-hour fire rating for the product. It's meant to be used with heat strengthened, tempered, UL listed fire protection rated glazing products. Again, this product is also found in Bulletin 181. So we have one bulletin combining all window sprinkler products. We have flat plate concealed is the aesthetic that you're going to get after this. It's a 5.6 K factor. This uses our model G5 plate that's a push-on thread-off design. It's the same for all of our flat plate concealed sprinkler products out there. We have intermediate and ordinary temperature options. And again, we wanted to make sure we have a 250 PSI available to our customer base should they want to take advantage of that. Now, the sprinkler finish is unimportant when we're talking about conceal. What is important is the cover plates. So we offer 2 standard finishes, white and chrome. We have 8 special finish applications that are available for use with these products. And always we have custom colors available. We can match any paint color that's available to truly deliver a blended, seamless aesthetic. If we take a look at the applications for this product, again, looking at it being used on an interior wall, we have flat plate concealed on both sides of this product, or both sides of this wall assembly, because we don't know which side of the windows fire is going to start on. We also have the ability to use this on an exterior wall as long as it's on the inside. We install that product, it can activate automatically and protect that window from exposure issues. And then again, because it's the interior of an exterior wall, we're going to want to follow guidance pretty much laid out by NFPA 13 to recommend intermediate temperature sprinklers for that type of assembly. If we look at using this on the exterior of a building outside, well, you know what? That really isn't going to work because this is meant for deluge systems. So the WP56C, even if you remove the operating element from it, we still have a concealed cover plate on top of it. So it really just doesn't mix well with deluge applications. So it's not going to be acceptable to use this on the outside of a building in this exterior exposure application. If we look at the WP56C installation using vertical mullions, we have the ability to space it 6 foot minimum for cold solder unless it's separated by a baffle. And it has a maximum of 10 foot in between these sprinkler products. Now, this is the industry's best spacing offered by concealed window sprinkler. It is 2 foot less than what we offer with our fixed frame version of the product, but it does offer a significant increase versus anything else out there. We also have a 5'6" maximum measurement off of a mullion available. And if we take a look at installing this with butt joints, again, the butt joints are key because they really space everything out and allow us to maximize the spacing. For a minimum, it's 6 foot. For maximum, again, it's going to be 10 foot. And again, we're going to have a 5.5 foot measurement off of a mullion. Horizontal mullions are going to present the same challenge with this product as it did previously with our fixed frame version of the products. So again, the intermediate horizontal mullion is going to need to have some kind of attention paid to the lower panes of glazing down here. If we take a look at our glass types and wall assemblies, again, we have the setup here involving the UL listed fire protection rated glazing material. 13 foot maximum, nothing changes from concealed. We have no maximum height as well. We have installing this in the fire protection in glass types other than the fire protection rated glazing material. So our heat strengthened and our tempered glazing, we're going to need that pony wall once again. We have no maximum height, 13 foot. And installation dimensions, we're going to install this product with the sprinkler's deflector guide pins aligned parallel to the glazing surface. And we'll set it back 6 to 12 inches. And we'll also look to set this product to plus or minus 2 inches from the window frame. Now, another way to describe that measurement that might be easier to process is it can be installed 0 inches above the window frame all the way up to 4 inches above the window frame. Let's just think about this for a second on how it compares to our other window sprinkler product. We installed that product 4 inches away from the glazing as a minimum, and we also installed it 2 to 4 inches down. In this instance, we're now installing this product a little bit further back and then definitely way higher than it was before because we're flush with the frame or all the way 4 inches above the frame. So big differences with this sprinkler position-wise. Sort of helps you understand why maybe the 10-foot listing comes into play, because it's harder to really cover the surface of glazing material when your sprinkler is 4 inches above the glazing material. So spacing them closer helps us get that coverage of the glazing that we need. These sprinklers are very attractive to begin with, but if there is still a need to build a ceiling pocket or a desire to build a ceiling pocket, that can be done just to hide them even more. And also window treatments, again, not a concern. You're able to do it, assuming that the window sprinkler is in between the glazing product and the window treatment. Let's look at the listed flow and pressure for these products. There's actually 2 listings, and it's based upon the coverage area of the product. If you're able to do coverage area that's 6 foot to 10 foot, the flow rate is 20 gallons a minute. And if it's less than 6 foot, it's going to be 15 gallons a minute. Now you can start to see some more of the impact here of installing this sprinkler above the frame. Not only are we spacing them closer, but we're actually needing to throw more water. So in this case, it's going to be 5 extra gallons compared to our fixed frame version of the product. But that's sort of what you do. In order to get this better aesthetic, to be able to move this sprinkler above the frame, away from the window, it's going to require tighter spacing versus our regular products, and it's going to require more water. The IBC, I want to just take a minute to talk about the IBC. A lot of times we get questions about how these sprinklers are meant to be implemented. And it gets a little bit convoluted because a lot of this goes back to the building code. If we look at Chapter 7, this is the chapter that's going to talk about structural fire resistance and fire resistant rated construction. And this is going to allow for us to use fire rated glazing, which is costly, weighs a lot, really just not the best way to go about maybe looking at doing a fire rated assembly that delivers the aesthetics of glazing. But it's found in Chapter 7. And when you look in Chapter 7, there's actually a reference to automatic sprinklers. And this was added in recent years to sort of, I think, discourage the use of the products we just talked about. It really doesn't spell out their use very easily, because it says under the prescriptive fire resistant requirements of this code, the fire resistant rating of a building element, component, or assembly shall be established without the use of automatic sprinklers. Right, so it's right there saying, hey, you know what? The window sprinklers that exist, building code doesn't necessarily want them, right? But if you read on a little bit, it talks about this section shall not prohibit or limit the duties and powers of the building official allowed by sections 104.10 and 104.11. So what is that? Well, that's the area that a lot of people like to turn to when you get into trouble with a building or a sprinkler system, and that's the part that talks about how do you build something outside of what's in these documents, and that's basically where it says that with proper validation, with new products that come on market, that you can do it. You can go beyond what's written in building codes or in NFPA 13. And really, it is a well-validated process. This isn't just, oh, I want to do it. It needs to be looked at scientifically and making sure that the products are validated to be used in the way that they are. That involves research reports and tests. Fortunately, the best way to utilize anything that is not found in the IBC is to look at the International Code Council Evaluation Service. This is essentially formally interpreted variances for the building code. This window sprinkler problem we just discussed, it actually has its own criteria. It's AC 385 at the ICC Evaluation Service. What it does is it looks at the ability to use the building code section 104.11, the alternative material section. It's also wrapping in the 2 UL test documents that we discussed and we went through with our products. It's rolling in another UL standard, which is the fire test of building construction materials. And then lastly, the ASTM E119 test methods for fire tests of building construction materials, the curve that we used in that furnace. So it takes all these things, puts them together, evaluates our window sprinkler products, and we come up with our ICC-ES evaluation report. So ESR-4700 was just issued in November. It's available on the ICC-ES website. We also have links to it on our website and in our bulletin for our products, but it evaluates all 3 of the window sprinklers that we just discussed. And it has the industry's most comprehensive scope with respect to building codes and various localized building codes throughout the world. So download it, take a look at it, and have some comfort in looking at the window sprinkler products offered by Reliable as applied as variances to what IBC is proposing for their fire-resistant construction. Now, just another touch on things, because the IBC was always the one that was looked at as how do we use these products, and there was also that section about automatic sprinklers really not wanting to use them. NFPA 13 was silent for a good while, but they ultimately decided that now's the time to consider adding some language, and it started in the 2016 edition of the standards. And then basically it's going to look at NFPA 13 and NFPA 13R, and they're going to take exactly the stuff that we just discussed. They shall be listed specific application window sprinklers. They'll be supplied by wet pipe systems. They'll be used on heat strengthened, tempered, or glass ceramic that is fixed. They'll use it for protecting both sides of the glazing on an interior wall. And if we look at, there's a couple more here. The use of sprinkler protected glazing shall not be used on load bearing walls. That should be limited to use on non-load bearing walls. The glazing assembly shall not have any horizontal members, the horizontal mullion stuff we discussed earlier. And the water supply duration needs to make sure that it matches the fire resistant assembly. So all those things from NFPA 13, they take into account exactly what the ICC-ES was wanting to see, what UL was doing with their test criteria. So it tries to roll it all up and put it into NFPA 13, something that's been adopted by the local municipality where this building is being built, and help tie everything all together. So IBC says what it needs to say. We have the ICC-ES report to help clarify using it with IBC, and NFPA 13 isn't a roadblock anymore for our newer standards. So window sprinklers are just continually getting more adoption and more visibility, and allowing the architects to realize their vision using glazing in their properties. So just in recap here, why would we choose Reliable window sprinklers? Well, with the fixed frame versions of our products, we offer the best spacing, up to 12 foot. We have the best spacing off of a mullion, reaching 7 foot. We have the best flow rate per sprinkler at 15 gallons a minute. And we have the best pressure rating of 250 PSI, a number that's untouched by any window sprinkler manufacturer. And we have the industry's only fusible link model. If you want the durability of the fusible link, if you are tired of orange protective caps being taken off too early in a project, or forgetting to take them off and going back on a punch list item, the WP56L might be the solution for you. And why would we want to choose Reliable for a concealed window sprinkler? Well, we offer the best spacing for concealed models, going up to 10 foot, 2 foot greater than anything else available on the market. We have the best spacing off of a mullion, 5.5 feet. Competition is 4 foot. We have the best flow rate per sprinkler. We are at 20 gallons a minute, all the way up to 10 feet. That is just an unheard of amount of coverage area per gallon per minute. And we have the best pressure rating of 250 PSI, again, allowing us to build our high systems. And as for some frequently asked questions before we get to your questions, can the window sprinkler be installed on systems containing antifreeze? Yes, it is acceptable. We want wet systems. Antifreeze is an alternative to wet systems. NFPA 13 has their requirements to use listed antifreezes. We would expect that our window sprinklers are used with that listed antifreeze per NFPA 13. Why can't window sprinklers be used on glass that's taller than 13 foot? Well, we talked about the furnace height limitation of allowing 13-foot pieces of glazing in the furnace. So the listed application for this product is 13 feet. If you have an application that's longer than that, you don't want to have horizontal mullions. Anything is possible to be looked at from an evaluation standpoint to propose a variance outside of our product's listing. One thing I will say about the physical aspects of this is that sprinkler, once that water gets going, and it starts cascading down the surface of the glazing, it's probably going to keep going beyond 13 foot. I feel that's going to be ultimately what is going to happen if you were to have a 15 or 16 or 20 foot piece of glass. So can the WP window sprinkler be used on glass that is installed on a slope? Our furnace had installed in an upright position. It was not evaluated for a slope. Not to say that it can't be looked at for that type of application. Two things to consider. How is the glass sloped? Is it sloping in towards the sprinkler or away from the sprinkler? Those are big things to consider. If it's sloping inward towards the sprinkler, that's probably the best case scenario because the sprinkler will activate, it will discharge water, and we know gravity is going to let that water go down, and the fact that it's sloping inward towards the sprinkler means that that sheet of water might end up just cascading all the way down without a problem. When the glazing slopes away from the sprinkler, though, we can't really count on the water to be able to adhere to the surface and cascade down it and not drip off of it. Those are all things that you just need to be considered. If you got some situations where you want to talk about this more, reach out to technical services and we'll be able to look at it in more detail for you. Can the window sprinkler be used on glass doors? Big part of these window sprinklers is fixed glazing. Glass door obviously is not fixed, so it goes outside of the listing. Once you're in that area, it's just really up to a discussion with the AHJ and figuring out a way if you guys can have it approved and be comfortable with the application. And now we could take some questions and answers from the audience, if there are any.
Awesome. And yes, there are, Brandon. We have some questions.
Okay.
Several, in fact, with regard to horizontal mullions. One of the questions is, if you were to put a soffit at the horizontal mullion, maybe to house the sprinkler piping or whatever, is there a minimum size for that soffit?
No, it's really nothing that is just prescribed as a minimum. It's sort of in uncharted territory. Ultimately, though, I don't think it's a concern on the size being too big or too small, because we focus on placing these sprinklers very tight to the glazing, and we also look at them not needing to be so much sensitive to activation. Like, that's why these sprinklers can be installed so far down from the ceiling. We're more concerned about, does a fire get close enough to that individual pane of glazing to activate the sprinkler? And then the sprinkler goes off, and then it coats the surface of the glazing. So I just don't think that there needs to be anything built there for a cold solder coverage concern or heat collection concern or anything like that.
Okay, so and as always, the AHJ will have the final say on that, as well as your architect, perhaps. And you mentioned cold solder. If a line of sprinklers were to be installed somewhere at a mid-level to those lower panes of glass, is there an issue from cold solder from the sprinklers above?
I would say no, because we don't have that concern with the top level sprinklers. We know that ceiling sprinklers are going to be above them and potentially activating as cold solder. I don't know. I think the answer is no. We've seen nothing in the way of guidance from UL in that regard at this point. I don't know. I mean, if you want to throw an intermediate shield on there that wouldn't be listed just for a little bit of extra comfort, you could. Or building out, like you said, some type of soffit to better shield it, you could do that as well.
Okay, so again, it points to one of the special natures of these sprinklers, that the AHJ will need to always be involved and to address some of these questions that are not otherwise addressed by UL. Related question, and you may have touched on it, but if you could elaborate, is there a cold solder distance between the ceiling sprinklers that would normally be there and these window sprinklers?
I can't find one. It wasn't really part of the way this document was laid out with the technical bulletin. We know we have window sprinkler cold solder distances against each other, but we never really discussed how far away the other ones are. I think that good practice would be to follow standard spray or the extended coverage guidelines or the guidelines of the sprinklers that are at the ceiling if they're different than those published by MP13. And if you absolutely cannot maintain them, then reach out to us and we can investigate some more to find out if there is a real definitive measurement.
Yeah, and I think the other thing that we'll do that Reliable will take on, we'll put that question in front of the folks at UL. It may be something that simply was unanticipated in the testing standard and needs, basically clarified at UL. So we will do that for them. Shifting gears a little bit. Shouldn't the window sprinklers spaced 12 feet apart flow 20 gallons per minute and not 15? So someone's obviously looking at a historical aspect of a sprinkler that's out there and wondering why we're not the same.
Yeah, I can't speak to why other manufacturers' products are listed the way they are, but I can tell you that the original products on the market had much tighter spacing and they had much higher flow rates. We went through the same tests that they went through, and our product performed with greater spacing and less water. That's really all I can say about it.
That's the answer. And again, it's another function of the special nature of the sprinklers, which is the requirements, the minimum requirements really aren't set for special sprinklers. We go in and experiment and perform the testing at the flows and pressures that we anticipate will handle the will meet the requirements of the test standard, and if we pass, that's the flow rates and pressures that we get. So it's really nothing more than some updated testing, perhaps a little more efficient sprinkler or deflector design. So at the end of the day, with the special sprinklers, we are not required to meet a historical benchmark that may have been out there for any number of years. Again, shifting gears, any intentions to pursue FM approval?
It's a very, very good question. To my knowledge, FM doesn't have a test standard for approving these types of products. I am not positively aware of an FM property using them, but I have a feeling that if an FM property needed this type of protection, that they would probably allow a UL listed product to go in there. But ultimately, that's a question more or less for FM to address with possibly a standard to approve these products or some type of statement on how they want to proceed with fire resistant equivalent glazing and window sprinklers. I don't really know.
So I would probably answer it a little differently and say that when there are FM approved products, FM will require their use. When there are not FM approved products, of which there are none of this nature, the folks at FM, the field engineers, people like that, can allow non-FM products to be used, and that's generally what happens. You need to remember that Factory Mutual does not sign off on the certificate of occupancy, right? The AHJ does that, and so he needs to look at everything. What Factory Mutual might do, it's hard to tell. I think every system is different, as they might. It may have an impact on the insurance premium because remember, that's the business that they are in. So in this case, with all the players involved, the building departments, FM, NFPA requirements, etc., the package simply has to come together at the end of the day to everyone's satisfaction. So again, the other thing that has to happen in order for us to pursue an FM approval is that FM must write a test standard. And currently there is not a test standard, to our knowledge, that Factory Mutual has for this type of product. So that would be kind of the way to answer that. Last question that's showing up here again is it's going back again to the horizontal mullion question, of which we've kind of already said that the AHJ has to get involved. And the question is, if there are 3 levels of windows, let's say you're at the wall of a pool, for instance, 30-foot ceiling height, 3 10-foot panes of glass separated by horizontal mullions, will window sprinklers be required at all levels?
If you're going to require them anywhere in that assembly, then all 3 levels are going to have to be protected. And as you said, it's going to have to default back to the AHJ accepting the methodology used to protect those 3 levels of windows.
Yep, I agree 100%. And last question, it's a very simple one for you, Brandon. The future of the Eagles, Carson Wentz or Jalen Hurts?
Wow, Jalen Hurts.
Okay, good man. That's all the questions. Appreciate it. Great job, Brandon.